Okay, I'll get started. So today I'm gonna talk about the attention mechanism in computer vision. And first, I will give you a little background, which consists of what is attention mechanism and why is it important. And then I will classify the attention mechanism into three types. The first one is about the channel attention, which explains what to pay attention to. And the second is about spatial attention, which explains where to pay attention. And the last one is just the combination of the channel and the spatial attention mechanisms. Okay, so the first question will be like, what is attention mechanism, right? So basically, attention mechanism are the methods for diverting attention to the most important regions of the image and disregarding irrelevant parts. For example, you're given by this image here, right? And I think at the very first glance, most of people will be captured or will be attracted by the sunflower here, right? So that's to say, this sunflower in this image is the most important part of that image, which will give you almost all the information of that image. So by focusing on this part or part of the image, you will know almost all the information of that image, right? So similarly for attention mechanism, it just aims to mimic this kind of property in the human visual system by focusing on the most important regions of that image. Okay. And also, why is it important? As I said in the previous slide, the first thing is that because important regions can capture more valuable information. So by focusing on this part of this part of the image, but not on the whole image, it can highly reduce the consumption of the computational resources. And also, we can improve our representation ability because the disturbances from the useless information and noise are ignored automatically. All right. And also based on the attention mechanism, we can have some important and interesting applications. For example, we can use it to generate the captions for a picture, etc. Okay, so first I will talk about the channel attention. And I will note that in this presentation, everything is established on the convolutional neural network. And because of the structure of convolutional neural network, the features of the image are extracted by fusing both spatial and channel-wise information, right? So in that sense, there might be some latent relationship among different channels, and channel attention just tries to capture this kind of interdependency among different channels. All right. And I will briefly introduce this seminal work called Squiz and Excitation Network. The structure will be like this. So like you have some input X that fed into some convolutional layer to give you the output U. So U is a feature map. So that part is the traditional convolutional neural network part. And this work just adds another block called SE block, where we have the squiz operation to capture the global information of each channel by just doing this averaging stuff. And after this averaging, everything of all the channels are fed into another network called excitation neural network to give you the importance of different channels. So the importance here is just the S, which is a scalar. So like if this S is a scalar is smaller, then that means the importance of that channel is lower, right? So in that sense, we can capture the interdependency among different channels. And then I will move on to the spatial attention. So like its name is pretty straightforward, right? So like in spatial attention, we just want to capture the interdependency among the positions of different pixels. So like we just try to learn which part of the which part of the image is the most important. All right. And I will focus on a work called RAM, which is a very smart work that combines the reinforcement learning approach. So in this work, you can imagine each image as an environment, and there will be an agent that tries to explore in this environment. So at each time step, the agent just can observe part of the environment. For example, in this context, it can just observe part of the image and to process it. So like it just process part of the image, but not the whole one, which means the computational complexity will be highly reduced, right? And based on this current observation, this agent will output an action which specifies which part of the image to be observed in the next time step. So by doing this sequentially, this agent will finally find which part of the image is the most important to us. All right. And finally, I will briefly talk about the combination of both channel and spatial attention mechanisms. So I will introduce a work called a convolutional block attention module, where it just tries to learn the interdependency among channels and spatial positions simultaneously. So the idea will be like this. So you will have some feature map F that fed into the channel attention module to give you the importance among different channels. And by considering this importance among channels, this new feature map or the refined feature map F prime and then fed into another spatial attention module to give you the interdependency among different positions of the pixels. So that's the idea, which is pretty straightforward, I think. And okay, so there are also a lot of other related works that in these three types of attention mechanisms, but I will not have time to introduce in detail. So just try to contact me if you're interested in. Okay, so that's all about this talk. Thanks.